In this video we're going to look at finding the equation of the tangent to a curve. The tangent is a straight line, so how do we find the equation of a straight line? The equation of a straight line with a slope m and passes through a point A and B. How do we find the equation? The equation would be y minus the y coordinate of the point, which is B, over x minus the x coordinate of the point, that is A, is equal to the slope m, which can also be written on the form of y minus b equals m times x minus a, or I can even move that negative b to the other side, which would be y equals m times x minus a plus b, where a and b are the two coordinates of the point that the straight line passes through. So how can we use this now to find the equation of a tangent? Let's consider the curve of a function y equals f of x. And let's say at a certain point here, where the x coordinate is a, therefore the y coordinate can be found by substituting into the function. So if the x coordinate is a, the y coordinate would be f of a. So at this point here, let's say that there is a tangent to the curve. The tangent that touches the curve at this point here, a and f of a. How do we find the equation of this tangent? We know that using derivative, we can find f dash at a. So if I differentiate the function and find f dash and substitute the point a, this will give me the slope of the tangent at this point a. So now, knowing this slope, f dash of a, and the coordinates of the point, which we call the point of contact, knowing the slope of the tangent, f dash of a, and the point of contact, we can find the equation of the tangent. So the slope is f dash of a, the point is a and f of a, so the equation of the tangent is y minus the y coordinate of the point of contact, that is f of a, over x minus the x coordinate of the point of contact, that's a, is equal to the slope of the tangent, which is f dash of a. So that's one form. If you cross multiply, you will get y minus f of a is equal to f dash of a times x minus a. Or you can also move the negative f of a to the other side, you'll get the equation y equals f dash of a times x minus a plus f of a. So this now becomes the equation of the tangent in the slope-intercept form. So let's look at an example. The question is, find the equation of the tangent to the curve of f of x equals x cubed minus 2x minus 1 at the point where x is equal to 1. So the first thing I'm going to do is to find the point of contact. So the point of contact The point of contact is 1, and to find the y-coordinate you need to substitute 1 into the equation. So it's 1 and f of 1, which is 1, and when you substitute 1 here you get 1 minus 2 is negative 1, minus 1 is negative 2. So the point of contact is 1 and negative 2. I now need to know the slope of the tangent, and to find the slope of the tangent I need to find f dash. So the derivative of this function is 3x squared minus 2. And to find the slope of the tangent, I need to substitute the point. And I need to substitute 1 into the derivative. So f dash of 1, that would be 3 times 1 is 3 minus 2 is 1. And now the equation would be y minus the y-coordinate of the point of contact, so it's y minus negative 2, over x minus the x-coordinate of the point of contact is equal to the slope, which is 1. Cross multiply, you get y plus 2 is equal to x minus 1, and this will lead me to the equation being y equals x minus 2 minus 1 minus 2 is minus 3. So this is the equation of the tangent at the point where x equals 1. The question can go on and ask to find where the tangent meets the curve again. Where the tangent intersects with the curve again. So the original equation of the curve was f of x equals x cubed minus 2x minus 1. And the equation of the tangent, we found it to be y equals x minus 3. So I'm going to call this y1, and y2 is the tangent. And now this involves solving them simultaneously to find the points of intersection. So I'm going to let y1 equal to y2, which will give me x cubed minus 2x minus 1 is equal to x minus 3. Move them all to one side to make it a zero equation. So that would be x cubed minus 3x plus 2 equal to 0. And then from here I factorize it. And to do this I'm going to use the equation, the calculator. So using the calculator I'm going to go to menu and then equations. These are this is a polynomial, so f2, and it's of the third degree, and then enter the coefficient. So a here is the coefficient of x cubed, which is 1. The coefficient of x squared is 0. We don't have an x squared here in the equation, so it's 0. The coefficient of x is negative 3, and the coefficient or the constant term is 2. Then enter. So I get two roots. Either x equals 1, and that times 2 here means it's a repeated root, so x equals 1 repeated, or x equals negative 2. So either x equals to 1 repeated, or x equals negative 2. X equals 1 repeated, this is where the tangent is. This is where the point of contact is. This means the other point where the tangent meets the curve is at x equals negative 2. So the other point is at negative 2 and f of negative 2. So when I substitute this into the equation, -2, so you can either substitute it into the equation of straight line or the curve, it doesn't really matter. It would be easier to substitute here. So -2 minus 3 is -5. This means the tangent meets the curve again at -5. If I look at a graphical representation of this scenario, this is the curve of the function y equals x cubed minus 2x minus 1. This is the point of contact, 1 and -2. This blue line here is the tangent that has the equation y equals x minus 3 that we found using calculus. And this point here is where the tangent intersects with the curve again. It's the second point of intersection. So the tangent touches the curve here at the point of contact, and then cuts the curve again at the point -2 and -5.